Hello students, today we are talking about gates, logic gates. If you consider the MCQ paper, we will be getting one MCQ from logic gates, and from the essay paper we will be getting one part from logic gates. So if you have noticed in the essay paper, normally if there are three parts A, B, C, the last part that consists with logic gates. In certain years, actually, student, even especially in 2012 question, the complete entire question actually that is from logic gates. So that can happen. Every year we have to face a logic gates question. Very rare. In certain years we don't have a logic gate question. So we have to expect that we will be getting a logic gate question for sure. So you have to be ready for that. Alright, today plan is to be ready for logic gates questions. I hope you have a certain kind of understanding about logic gates, but I'll brief through it. Logic gates for sure, but still I'm going through a couple of scenarios where you have to design a logic gate, right? Let's get into the question. Stay tuned. From gates, these are called the big three. A, this one, it's an AND gate. C equals A dot B, and C here, or the second one here, that's an OR gate where A plus B equals C, and the last one is a NOT gate where it will give the inverse of the input signal. So C equals A bar. You have to know these things. These are the primary main gates actually we have in our syllabus, but there are other derived gates as well. Let's move into set of questions and then we'll find out. Right, students, other than these big three, we have to know once NOT gate and AND gate is connected, we will be getting a NAND gate, and the output C will be equal to A dot B bar. Whereas at the same time, we will be getting a NOR gate actually while connecting a NOT gate and OR gate. So A, B, C, so A plus B bar, that will be equal to C. And the last, yes, this is the fifth one, right? There's another one. Normally in our syllabus, we have to face this XOR gate. Especially C here, A, B, C equals A plus B like this. In this one, if the input signals are equal, the output signal will be low as in 0. Say now if these two are 1, C is 1 and 0, 0, again 0. If both input signals are same, the output will show now 0, right? And I'm not going to show you the truth table for sure here, but you are supposed to know the truth table, right? Students, now in the questions actually, we'll be getting mostly I'm actually concerning here the essay paper. So in the essay papers, we'll be getting questions with a scenario. There will be a story behind it. So from the story, we have to come up with a logic level, logic expression, and a truth table. Mostly when you are designing a question, designing a circuit, actually what you have to do is you have to write the truth table first. So I'll give you one example here. Now we are doing our very first question now. So question will appear here, right? Yeah, question will appear here. Let's read out the question. Imagine you are designing a simple security system for smart home, right? The alarm should only trigger if the two conditions are met. So these are the two conditions. A motion sensor detects a movement and the main door is unlocked. Yes, and the question one, what kind of logic gates would you use to represent this scenario? So again, we are imagining you are designing a security alarm, smart home. The alarm should only trigger if two conditions are met. Here the motion sensor has to be triggered and the main door has to be opened. So let's write down A and B. So I'm allocating actually A, main door open. So main door open. So here students, remember that in normal day-to-day scenarios, we have to get into binary scenarios. Say binary means 1 or 0. So if you have something red and there's something yellow, say now red has to be 1, and yellow has to be 0, right? So there are only two options. So we are getting main door open. I hope you understood it. Main door open 1 and main door close 0. And then again, there's this motion sensor B, motion sensor triggered 1, and if it's not triggered, 0. So they are telling the alarm should go on if only these two are met, and two both are triggered, like both signals are triggered. Right. So let's draw the truth table. We have two inputs, so 2 to the power 2, so we'll be getting 4 combinations, right? So these are the combinations: 0 0, 0 1, 1 0, and 1 1, right? These are the options we have. Main door closed 0, motion sensor not working, motion sensor off, right? So here 0 0, then we don't need the alarm, right? 0. B1, so motion sensor is like now it's been triggered, but still the door is closed, no need. And again main door is open, but still the motion sensor is not in operation, so no need. Both are triggered. The door is open and motion sensor is triggered, so alarm has to go on, right? So here it's 1. So this truth table, actually students, familiar one, right? This is the truth table of, yes, the NAND gate. So we have to design a NAND gate. So A has to be there, B has to be there, C. So this input will go to the alarm, right? So it will signal, it will ring, right? Obviously, right? So there's another addition to this question. Let's read on again. Next part. How do you modify this system so that the alarm trigger, regardless of the other two conditions, this has to be once a window is open, right? Regardless of these two situations, even if this is met or not, but still when a door is open, a window is open, the alarm has to go on, right? The alarm open, the window open, right? Window opening, so window open, right? Yeah. Let's say W. So open window, we can take it as 1 and close window 0, right? So irrespective of these, right? If window open is 1, we have to have a 1. So in most cases we will be getting 0 from these, but here if this is 1, irrespective of these are 0, but still if this is 1, we need to get, if say now if W is window open is 1, we need to get 1. So 0 plus 1, 0 plus 1, 0 plus 1. That's an OR gate, right? So this is how I connect it. So this has to be connected by using a OR gate. So here this is how we do it now. Little bit of modification. It's like this, right? We have AB for sure, and this output, and here again we have window open. We connect it through a, say this is now alarm, right? So even if this is 1, even if this is 1 and if this is 0, still it goes on, right? So this is the output circuit. Actually the circuit we have to design to get this output. Students, this is a bit of a simple one, but we are getting into the questions now. Let's move into the next scenario and we'll see how it should be designed. Right students, we are in our second scenario now. Right here, it's actually almost same as the first scenario, but we have to the conditions are maybe a bit different and all that. So let's keep reading. question will appear here very soon, right? You are designing a simple circuit for an automated fan in a laundry room to prevent moisture buildup. For the fan, the fan should turn on automatically under specific conditions. Fan must turn on of the laundry room if the laundry machine is running and the door is closed, the room door, right? And it's the alternatively fan should also turn on the humidity sensor detector, right? Okay, right. So in this, it's quite similar to the previous question, but I'm going to go for a different approach here now. So let's write down their conditions. First one, say now A, laundry machine. So they have given it as L, right? Yeah. So if the laundry machine is in operation L, so it's 0, it has to be 1. If the laundry machine is working, it's 1. If it's not working, that's 0. And the door is closed, 1, and door is open, 0. Right. And the third option, humidity sensor, right? If the humidity sensor detects on, that's 1, and unless it's 0, right? So we can design the AND gate and OR gate method actually for this one as well, but here I'm going for different approach. So to this one, I'm just writing down the truth table. And here we have 3 inputs. So 3 inputs means, so 2 into 2 to the power 3, that's 8. So there are 8 possible combinations for the truth table, right? So I'm going to draw it here. It's not A, right? It's L. L, D, H, right? So we have to have 8 combinations. Students, remember that. This is actually one of the method, like we can use the previous method for sure, but in certain questions actually they ask us to draw the truth table. So if you have to design the truth table first, actually this method actually really useful, right? Try different methods, so practice, right? So I'm going to write the possible combinations. So I'm going to write 0, 0, 0, 0, 4 zeros and 4 1, right? 4 4 4, right? And for next one, wait, right, this is 7 and 8 combination, right? Okay, for next one I'm going to use 0 1 0 1 0 1 and 0 1, 0 0 1 1 0 0 1 1, right? So now let's look at the conditions they are asking from us, right? All goes 0. I mean, we don't need the fan, right? If the fan is F, we don't need the fan, right? And yes, door is closed, but the machine is not operating. These two both has to be 1, right? Otherwise the fan will not work, right? So again, no humidity sensor. So again here 0 0. These two are not in operation, but still humidity sensor is on, so we need the fan. Humidity sensor on, we have to have the fan, right? 1. Humidity sensor on, we have to have the fan. And humidity sensor on, we have to have the fan. Yes. Again here, we have to have the fan, 0. So this is another method that we can draw the truth table. If they only ask the truth table, actually from the question, we can give away this truth table as well. Remember that, right? And there's this method is bit of a longer method, but a bit of a complex method, but still this is correct. This is how you do it when you are designing the circuit. So we have to make sure. Let's consider all these ones. So we have like 5 scenarios, right? So this will be, so we add them actually by using an AND gate, right? If we use 3 input AND gate here, 0 0 0 0 0 1, that will be 0, right? But here we are using an alternative method actually. If this is 1, like we can make this 1 by making it connecting a NOT gate to this one. So L bar, D bar and H will give away 1, right? So I'm going to write it like this. L bar, D bar and H. That's 1, right? Right. So in that manner, I'm going to write all these 5, right? So this is a longer method, but it's correct, right? If you cannot find out any other method, this is the method you should follow, right? So 1, 1, so here L bar, right? L bar dot D and H. And the third one, L dot D dot H bar, right? Okay. And the fourth one, L dot D bar dot H. And the last one, L dot D dot H, right? The last one, L dot D dot H, if you can see that, right? So now all these actually we have to connect by using an OR gate. So even one of these are 1, so we have to have the fan 1 output, right? So what I'm going to do is the expression has to be something like this. F equals here first one, L bar dot D bar dot H, again plus second one, L bar dot D dot H, right? Next one, L dot D dot H bar plus fourth one, L dot D bar dot H plus L dot D dot H. So I'm going to connect it by using brackets, right? Boolean expression. Longer one, you can draw this as well by using 3 input NAND gate, and this is correct. Say now students, in some scenarios actually, just so I'm telling you students, just go through with the answer scripts like marking schemes, and when they have given the marking schemes and in the answers you will see these type of answers. So you will make sure that you will have the confidence to do these type of questions by using this method. Say now in some questions actually it's really hard for us to identify which kind of a gates we have to use, but this method definitely you can get the expression right. This is right, and you can draw it easily, right? Try this method as well, right? The previous method by using just AND gate and separately using an OR gate, actually we can get this done for sure. That of course you understood by that method. If only that didn't come to your mind, so you are the blank position, so you cannot give the answer. But this is a universal method. If you try this method, it works. Give it a try, student. Right. Moving into the. Alright, students. This is the biggest headache for some students actually. This is SR flip-flop. Right. This particular logic gate actually it can store certain data, 1 digit actually. It can be 1 byte actually. Z1 or 0, it can store, right? From the previous signal, this circuit can remember previous signal. So that's now we are talking about machines which can think and all that. So this is the beginning of it actually. So this is the start of it. So this particular circuit can remember what was in the previous signal, right? In the shortcut method actually, students remember that you don't try really hard to understand this one. If you do not understand this one, what you have to do is this. Just like you studied the previous logic gates, just remember, try to by heart the truth table and the output of the truth table, just remember them and just write it down when you come across a question. That's the easiest method. You don't have to go through deep into the logics here. But still I'm going to go through it, but even if you do not understand, just forget it. But let's write down the truth table here first. So truth table you must remember, right? So again here we have only 2 inputs. Remember that these 2 other inputs actually from the circuit itself which will give into the circuit, right? So basically we have only 2 types of inputs, R and S. Right? Say now we have R here and we have S. So basically we can have 0, 0, right? 0, 1, 1, 0, and 1, 1. These are the possible outcomes, right? for input signals. Right. Output signals, students remember that. Remember this thing. This circuit can remember previous signals. Say now we have two previous signals. Hope you can see here. Up to here, right? Hope you can see. It's Q and it's Q bar. Remember, these two output signals actually will give inverse signal. So if this is 1, this has to be 0. If this is 0, this is 1. Right? Exactly opposite. Right. Remember this thing. If reset, we call this actually SR flip-flop or SR flip-flop. Yes, SR flip-flop simply because it's set, reset. Set, this is set and this is reset. You press the set button, something goes on, alarm or something goes on, and you press the reset button, it is off now, right? Something like that, right? Then 0, 0 situation comes up. If reset is 0, set is 0, if both are 0, it will show the previous signal. So if earlier if Q bar was 1 and 0, it will continue to show the 1 and 0 signal again here. If 0, 1 was there, if earlier Q was 0, Q bar was 1, still output will be same. So these two, both of them can be correct. So you can write, it will show the previous signal. Right? It will show the previous signal. Right? That also you can write down. And once the set is 1, obviously when the set is 1, student, it's easy because if set is 1, the alarm or whatever it's connected to, it has to go on, right? If the set button is 1, Q, it has to be 1. Remember this. And Q by 0, inverse. Then again, if you reset it, obviously Q has to be 0, is 1. And we call 1 and 1 invalid signal or forbidden. Like if there's a circuit and you press set button and reset button both, and the circuit will not have a clue what to do. So simply like that, it won't give any signal here. Right. So we call it forbidden, right? Or invalid. This you have to remember. So if, again I'm telling you, this is how you have to remember it. If R and S both are 0, it will show the previous signal. If previous signals were 1 and 0, again 1 and 0 will come up. And if the previous signals were 0 and 1, 0 and 1 will come up, right? And again, if the previous, if it's R is 0 and S is 1, it will make Q 1. And if reset is 1, it will make Q 0, Q 1. Just like that. Remember this. Alright, right. So if you want to go deep into the question, I'll give that explanation in the next chapter. Right. This is actually for the students who wants to go deep into the question. We are going deep. Right. Okay, students. So we are applying the logic signal now. Here we have a NOR gate, N-O-R. Right. O gate and a NOT gate. O gate and a NOT gate. Simply that. Right. So let's assume, we are starting from this, right? Let's assume previous signal Q is 1, Q bar is 0. Right. So at the beginning R and S. Now the signals are R and S. Okay. 1. Okay, that this signal will come up here, 1, 1, 0, right? Through the O gate, it will be, yes, 1 and 0, it will be 1 by, from the NOT gate here, it will make 0 correct. Now we get this 0 up to here, here we have this 0. 0 and 0, through an O gate, it will be 0, but through the NOT gate, it will convert into 1, correct? So it will show the previous signal 1, 0. Let's say previous signal was 0 and 1. So let's remove this one. So previous signal, earlier we used 1 and 0. Now we are changing it here to 0 and 1. So previous signal 0. Right. This 0 will come up here. And here we get 0. 0 and 0, and that will be 0 from the OR gate, but because of the NOT gate, it will convert to 1, correct. And this 1 will come up over here, and 1, 0, again that will be 1 from OR gate, but from the NOT gate again converted to 0, correct. So 1, 0 and 0, 1, both outputs are possible. So it will show the previous signal, obviously. Right. Moving into second part, where S is 1 and R is 0. Right. Okay. So here we get, let's assume 1 and 0. Right. Okay. The output signal, the previous signal, 1 and 0. This one come up here, so it will be 1 here, 1, 0. 1, 0 will be 1, right, from the OR gate, and through the NOT gate it will be converted to 0, correct. And this 0 will go up here, okay, right, 0 and 0, that will be 0, and through the NOT gate it will convert to 1. So 1, 0 is possible, and it's a, student, let's try whether 0, 1 output is possible. So this is correct. Let's say 0, 1 output is possible. 0, 1. Okay. Now this 0 will come up here. Now it's 0. 0, 0 through the OR gate, that is 0. And from the NOT gate, that will be converted into 1 gate. So far so good, it's correct. Right. This one will come up over here and it will be 1. 1, 0 from the OR gate, it will be 1. Correct, right? It will be 1. 1. Okay, it was, no, it's correct, right? Yeah, 1, 0. 1, 0 will be 1 from this, it will be 0, that's correct. 0, 0, right, students. Now we are moving into the second scenario here, where S is 1 and R is 0, right. Let's start with previous signal 1 and 0, right. 1 come up over here, just like the previous method we did. 1, 1, that will be 1 from OR gate, and through the NOT gate, it will be converted to 0, that's correct. And 0 come up over here, 0 and 0 through the OR gate, it will be 0, through the NOT gate, it will be converted to 1, that's correct, possible. Now let's see whether 0, 1 condition is okay. So 1, 0 is possible, right? So that's fine, right? Let's see, 0, 1 is possible. Okay, so let's change these values now. Right? Let's see whether Q1 is possible. 0 come up over here, so here it will be 0, 0, 1, that will be 1, and this NOT gate will convert it to a 0, right? Students, previously it was 0 here, and the Q bar has to be 1, but now from this gate it will convert it to 0, but this condition cannot be there. It's always, actually these two signals will be opposite of each other, inverse. So this condition will not be there. Only 1, 0 output will be as the output, right? Now let's move into where R is 1 and S is 0, right? We are making this R is 1 now, and we are creating this S is 0. Okay. R is 1, S is 0. Right, okay. Let's start with this condition of 0, 1. Right. 0, 1. Now we have 0, 1. Right. Okay. Let's check whether this is possible or not. 0 come over here, it's 0, 0, 0, 0, 0, 0, right? Through the OR gate, 0. Through the NOT gate, it will be 1, correct. And this 1 come up over here, 1, 1, that will be 1. And through the NOT gate, it will be 0, correct, right? Right. This signal is true. Let's change it now to 1 and 0. Okay. So I'll make this is 1 and I'll make this 0. Okay, this one come up here, and we get 1 here. 1 0 through the OR gate, that will be 1, and this 1 will be converted to 0. That's correct. Okay, so far so good. And this 1, that's 0. 0 1 will come up here. 1 0 will be 1. It will be converted through the NOT gate to a 0. So 0 is not possible there. Only 1 is possible. If this is 0, if Q bar is 0, Q has to be 0. Q has to be 1, right? So this condition is not met. So this situation is not possible. Only 0 1 condition for Q 0, Q bar 1 is possible. Right? So these are the valid responses now. So let's see the invalid one. Let's check whether what will happen to the invalid one. Invalid one, let's say the input, previous signal 1 0. So invalid one, S and R both has to be 1. Okay. 1 1 1 1 through the OR gate will be 1, and it will convert to 0. Right, done. Okay. And this 0 will come up here. 1 0 is 1, and it will be converted to a 0, but 0 is not only, it's not possible, only 1 should be there, because the output signals should be inverse of each other, so that's not possible. That's why we are not using this 1 1 signal. For both scenarios, it's not possible. Even if we use 0 1 over here, it's not possible. Let's try that as well. And it's complete. We get 0 here, we get 1. Right. So we have 1 1 here. 0 here, now 0. Right. 0 1 through the OR gate, it's 1, and through the NOT gate, it will be 0. But here it has to be 1. Because if this is 0, here it has to be 0. If this is 0, here it has to be 1. But through the gate, it is converting into 0, but that's not possible. So 1 1 condition, we say it as invalid, only these has to be there. So students, you don't have to go these 3 factual into, but for the better understanding, this is helpful. You have to remember this, right? So what's the thing again? If R and S both are 0, it will show the previous signal. 0 1 1 0 possible. Q has to be right. And if S is 1, Q is 1. If R is 1, Q is 0. Remember this. Right. Let's get into a question and let's see how we apply this one. Right. Right. Students, now we are in the third segment. Right. Here, now we have a scenario. Right. They are giving us a question. Let's read it. You are asked to design a safety circuit for an industrial conveyor belt. The conveyor belt should only start moving when start button S is pressed. It must start running after the button is released. The only way to stop is by pressing stop button. Right? Explain why a simple logic gate cannot solve this. Right? Actually, from the question itself, it is telling that we cannot use a simple logic gates here. Right? But let's try using a simple logic gate here other than using a flip-flop. Actually, we have to use a flip-flop here. Let's say here we use a push button. Right? So this is the conveyor belt. It will operate once this push button shows 1. So once it is pressed, it will be 1, right? So the conveyor belt will be getting 1 signal. So it will start running. Okay. Done. So once this is 1, it will start running. But when you stop pushing the button, you press the button, right? So it will be 1. Okay. Now it starts running. But now you stop holding the button, you release the button, so it will be 0 again. And 0 will be there. Stop. Right? Even if you use an AND gate, even if you use an OR gate, so whatever you use, it once you stop pushing the button, it will show 0 signal. Once this 0 signal is there, the belt will stop it. So in this circuit, actually circuit itself has to tell the button that once button is pressed 1 time, you have to keep running, right? So here the circuit has to remember that. I mean, okay, right now we press one button. Right now the conveyor belt is running. Now once you release the button, it will show you. Now the circuit has to remember, right, my previous signal was 1. Now I get 0 as a signal. What should be my output? Right. So if it's a flip-flop circuit, just like we discussed earlier, previous signal. So when the button is connected to let's say now the button is connected to reset here, P. So P is here. Pressing the button is here. So it's 1. You connect it to S and R is 0. Reset is 0. So you connected to reset button, P is 1. So if set is 1, reset is 0, Q is connected to the conveyor belt now. Right. Q output is connected to the conveyor belt now. Right. Now we press start button, Q will become 1. Right. If S is 1, R is 0, Q is 1. So belt start running. Right. Now you stop holding the button. You release the button. Now S will be 0, right? And R is 0 as well. When input signals are 0, it will show the previous signal. What was previously? Previously it was 1 and 0. Right. So it will continue to show the previous signal 1, 0. So it will continue this belt running. The belt will run continuously. Easily. This is how you cannot use a normal simple logic gate to this repeated. Oh, this circuit has to remember what was the previous signal. So here we have used SR flip. Students, if you go through past paper questions, you can find there are a couple of questions actually from flip-flop. So go through with that questions as well. Then you will clearly understand how these questions are incorporated into your questions, right? Students, remember that you have to practice this application. This is a very simple method that I'm using to explain it to you. Just I have used 3 scenarios, of course. So if you need many questions actually from this type of questions, please let me know. I'll give another set of questions for sure. So try to remember. Here you have to remember this truth table. Students, remember that. So SR flip-flop is not hard actually as far as you remember this truth table. So again, I'm telling you my advice always, keep practicing, students. If you keep practicing and use the marking schemes with you when you are practicing essay papers for sure. So, students, as I always tell it to you, practice is the key here. So you have to keep practicing for sure. Find similar type of questions and try questions. Lots of questions you have to practice. Not too much, not too little, just the right amount. You have to figure out the right amount of questions that you have to do. But otherwise, it will pile up and you won't be able to do the question. So, but here, if you are planning to do electronics as a question, you have to ready for SR flip-flop. You might there might be a chance to get a SR flip-flop question. Even if we get an MCQ question from this one, you must be ready for that, right? So nowadays the pattern is that we'll be getting all the type of questions, say now from, as I previously mentioned, transistors, diodes, op-amps, gates and everything will be together. So we have to be ready for that, right? Students, so you have to go through the marking schemes, because only the marking schemes we can see that the natural method, they give the answers. The structure you have to put the answers and all that. So keep practicing, students. Practice